Hi students, today we are going to learn about electrochemical cell. I will discuss the basic concept in electrochemical cell. In electrochemistry, we are having two divisions. Electrochemistry, it's nothing but the study of electrical energy through the chemical reaction. So electrochemistry is having two typical parts. One is electrochemical cell. Electrochemical cell. So which convert the chemical energy into electrical energy. Electrochemical cell is a device which can be used to convert chemical energy. So what is chemical energy? Have you got any chemical energy from the stoichiometric equation? Yes, actually we will get some heat energy, delta H. In thermodynamics, we have learned that, right? In 11th standard thermodynamics, there will be a release of heat energy, means it will be the exothermic reaction. So heat energy will be released. So the energy released from the chemical reaction is in the form of heat. But now we are going to convert the energy released in the chemical reaction by using some electrochemical cell device, and we are going to convert that chemical energy in the form of electrical energy, not in the form of heat energy. We are going to convert that in the form of electrical energy. So chemical energy will be converted into electrical energy. The device which is used for this will be called as electrochemical cell. And then further thing, electrolytic cell. Electrolytic cell. This is the device which can be used to convert electrical energy. For example, in endothermic reaction, we will use some heat energy to the stoichiometric reaction. That is, for the reaction, we will give some heat energy, and the energy will be absorbed by the reactant and the reaction proceeds, right? Like that, we are going to give electrical energy for some chemical reaction. So electrical energy will be used to proceed the chemical reaction. So electrical energy will be converted into chemical energy by using this device. But in this part, we are going to discuss only the electrochemical cell. This is the setup of electrochemical cell. I will explain each and every parts. Look at this. Then in this electrochemical cell, we have taken two parts. Here one part is having copper nitrate solution. Look at this copper nitrate solution. So copper nitrate solution, when you are dissolving the copper nitrate solution, you will get copper 2 plus ion and nitrate ions. So it will be completely dissolving into ionic aqueous form. So copper nitrate we are taking, and I will tell you the purpose of the copper nitrate. And then look at this copper electrode we have taken. Copper electrode, which is brown in color. Look at this. So this is a copper color, right? So copper is dipped in the electrolyte copper nitrate solution. So why I'm saying this is an electrolyte? Whatever may be the substance that is dissolved into ions, that can be called as electrolyte. So electrolyte, how can you define that? Anything that can be dissolved into ions. For example, KCN can be dissolved into ions, HCl can be dissolved into ions, KNO3 can be dissolved into ions, H2SO4 which will be dissolved into ions. So whenever the substance is having the capability to produce ions in water, then we can say that as electrolyte. So we are just taking that electrolyte. Why we are calling that as an electrolyte? Because it can conduct the current. The ions can be used for the conductance. That's why we are saying that solutions as electrolyte. So copper nitrate electrolyte is there, and we have dipped the electrode. What is the meaning for electrode? Which is the medium to transfer electron. So copper is a metal. That metal will be used to transfer electron. So the medium which is used to transfer electron will be called as electrode. So this will be copper electrode. And look at this. This is silver electrode. Right hand side, they have taken silver electrode. I will tell you why they have taken in the right hand side. Everything I will tell you about that. So silver electrode they have taken in the right hand side. And then look at this, the electrolyte used for this one will be AgNO3. So it will also produce ions Ag plus NO3. So it will be an electrolyte. So Ag electrode they have taken, corresponding electrolyte they have taken, and Ag electrode dipped in the electrolyte solution. And look at this, there is another one part. This is actually salt bridge. I will tell you what is the purpose of this one after learning this part. So actually look at this, we are just connecting, we are not producing any, we are not giving any current, that is we are not giving any battery supply, we just connecting these two parts, that is copper electrode will be connected to the Ag electrode. So in the case of reactivity, which is more reactive actually, copper or Ag, which is more reactive actually? Ag will be the less reactive one. How can I find out that one? From the reduction potential series you can find out. If you have analyzed that Cu2 plus solution, that is Cu2 plus, when you are adding two electron, this is called the reduction reaction. Reduction means addition of electrons. So when you are adding two electrons, you will get the copper. This is reduction reaction. When this reaction happens, the electromotive force, that is the voltage that can be released in the standard condition, not should be there at the superscript. So E naught Cu2 plus to Cu conversion, that is the voltage produced or the voltage created will be the positive voltage, that is 0.34. What it indicates actually, we are having one formula, delta G, that is the spontaneity measurement is delta G. If the delta G is negative, the reaction will be called a spontaneous reaction. And there will be NFE naught. That is the formula for that delta G. So if E naught is positive, delta G becomes negative. If E naught is positive. So here this process is called a spontaneous process. That is addition of electrons will be the spontaneous process for the copper. But in the case of Ag, look at this Ag plus, when you are adding electron, it will give Ag, and here look at this electromotive force created, that is voltage created due to this process will be 0.79 or approximately 0.8. So look at this, both are positive. So both wants to give only the reduction process, but which will give the higher voltage, higher energy will be released in which case? Here the higher energy will be released in the second case. Higher energy will be released in the second case. So delta G for the second case. I will take this as a second case, this as a first case. So delta G for the second case will be more negative than delta G first case. So look at this, I am not at all comparing that original value, I am just comparing the negative value. So negative value negatively increases. Here delta G negatively increases for the reduction Ag plus to Ag. So here it will automatically get reduced. When you are connecting that one, the more spontaneous will take place first. So more spontaneous reaction is taking place. So this is the spontaneous reaction when you are comparing this two. So the spontaneous reaction will be there in the reduction part. Look at this reduction. When you are doing reduction with Ag plus, then no other way for copper. It will undergo only the oxidation. So copper will get converted into Cu2 plus and the two electrons will be released. This is called oxidation. So oxidation will happen at one end, reduction will happen at another end. The more spontaneous reduction part will take the reduced case, that is the reduction case, and then the less spontaneous reaction, the less delta G value will give, the less negative delta G value will give the oxidation process. So what will happen here? We have taken two electrodes, right? Two electrodes part, the two half cells. It's not two electrode, two half cells. So electrode dipped in electrolyte will be called as half cell. So this half cell and this half cell. Look at this, we have taken two half cell. So in that one half cell, what will happen? Here copper will release less spontaneous energy, that is less delta G. That's why it will take the oxidation process, and then it will take the reduction process. What will happen? Copper will lose the electron and it will be dissolved into copper 2 plus ion. Look at this. Copper lost 2 electrons, and that electrons, after that releasing of electrons, copper could not be a metal. If it is a metal, then only it can stay in the electrode part. But now it has been converted into ions. Ions will be there. Then that is, it will be dissolved completely in the aqueous part. So copper is converted into copper 2 plus and get dissolved in the aqueous part, and the electron transferred from the copper part to that Ag part, and then the Ag part will accept that electron through the Ag electrode, and then Ag plus will be converted into Ag. Here the reduction happened, here the oxidation happened. Oxidation happen always at anode. Remember that oxidation means anode. Anode will have the oxidation, and the cathode will have the reduction. Look at this. Automatically it is taking the charge. How we can convert that? How we can take the charge for this one? Here it is losing electron. If it is minus charge, then only it can able to lose the electron. It should be the plus charge. That's why it is accepting that electron. So here cathode is positive, anode is negative. Remember that you could not fix the cathode and anode for this electrochemical and electrolytic cell. It will vary. So you have to remember one thing. So oxidation means loss of electron. So loss of electron happened only when there is a negative charge. So negative charge is there at the anode, but the electrolytic cell, it will be differing. I will give you that one in the next class. And then look at this here, negative charge. That is, negative charge means copper electrode loses its electron, and the electron is moved from electrons. So many electrons are moved from the copper part to Ag part. So movement of electron is nothing but current. That's why the bulb glows. So look at this, just movement of electron. Actually, we are taking the redox reaction. The redox reaction takes place, and we have separated the redox compartment and the oxidation compartment. That will create automatically the voltage difference. That voltage difference, because of that voltage difference, there will be a movement of electrons. The movement of electron leads to the bulb glows, right? Okay, then actually here so many calculations will be there. Nernst equation based on this part. I will explain the Nernst equation in our next video. Thank you, students.